done this before. So one way to think about it is if you have two containers, and these two containers are connected. Don't worry about that. So just imagine that they're connected. I have the line there connecting them, but you don't see where the fluid in one can actually enter the other. So let's just say this is container A, this one's container B. And let's just say in container A we have 25% solution of some salt, 25% salt. And over here we have 35% salt. Now, and let's just say they're connected, but there's a semi-permeable membrane between them that will allow some particles to move across and not others. First of all, let's pretend that that semi-permeable membrane is not there. So all particles on either side can move from one direction to the other. Okay? So if that were the case, in container A and container B, contents could move freely to either side. Which direction would the salt move? So we have 25% salt in A, 35% salt in B. So which direction would salt move? How many say from? So salt would move from B to A? How many say B to A? So y'all don't understand diffusion. Diffusion, no, just diffusion. We're going back to diffusion first, just so you all understand. So diffusion, define diffusion. Right, so movement of anything, any particle, from a high concentration of that particle to a low concentration of that particle. So salt, so if you have a solution of salt water, I guess you have to understand that first. If you have a solution of salt water, what is the solution? The solution has a what? A solute and a solvent. Right? You all remember that? So any solution has a solute and a solvent. So the solute is what's dissolved in the solvent. So solute is dissolved in solvent. So if we have a solution of salt water, salt would be the what? Solute. Water would be the solvent. So what you have here in container A is 25% salt, 75% what? Water. In the other container you have 35% salt. And how much water? 65% water. Okay? So now, if salt can move, if you understand diffusion, you know which way salt is going to move. Right? Salt is going to move from B to A. Right? Everybody with me? So diffusion is movement of any substance from high concentration of that substance to a low. So salt would move from B to A. Now, in our body, we have cell membranes that are semi-permeable. They're not going to allow salt to move. So that's why I put this imaginary semi-permeable membrane between the two containers to show that, okay, salt can't move, but water can move. And when water moves, water is going to move by osmosis, right? So diffusion of water is osmosis. That's simple, but like I said, you have to understand diffusion first. So if water can move, which way will water move? Okay, so this container has 75% water. So important to understand this going forward. And since there's 35% salt, there's 65% water in this container. Okay, so water moves which way? Water moves from container A to container B. Whereas we said salt moves from container B to container A. You get it? Everybody get it? Now, and you always hear that water follows salt. Now you know why. Because wherever salt is a higher concentration, water is a lower concentration. So it's really following salt, but the reason it's following salt is because water is just diffusing from where it has a higher concentration to where it has a lower concentration. Okay? Now, so when we think about osmolarity, all I want you all to do there, osmolarity has to do with the amount of solute in solution. So whenever you see something talking about osmolarity and it says one compartment has a higher osmolarity than the other, all you should think about is that osmolarity is referring to solute concentration. So if I increase the osmolarity in container B or A, let's just say we increase the osmolarity of container A, and it's going to depend on how much we increase it. If we increase it to 30%, it's still going to be a lower concentration than container B. So you're still going to have diffusion in the same direction, but it's not going to be, remember the steepness of a gradient, concentration gradient, the steepness of the gradient determines how fast the diffusion occurs. Not a big deal. But in thinking about osmolarity, okay, now let's go back to the slide here where it says that last bullet point, if imbalances arise, osmosis restores balance within seconds. If osmolarity of tissue fluid rises, water moves out of the cell. If osmolarity of the tissue rises, so what you should be thinking here is everything's balanced, right, between tissue fluid and cells. Let's look at the next slide first. Actually, I wanted to show you on this one. So when you look at this slide, what it's showing you is that water moves between these various compartments. And so kind of spend time looking at this and making sense of it. So we bring water into the body when we drink, correct? So drinking water ends up in our digestive tract, but it immediately is absorbed into the what? Into the bloodstream. So it goes into the bloodstream. Now, in the bloodstream, water circulates and the kidneys get rid of any excess. But what happens when the water gets in the bloodstream, some of that water can move into the interstitial fluid, the tissue fluid. Okay? Now, what we're talking about here is what determines if that water is going to move into the tissues or if fluid from the tissues is going to go into the bloodstream. So you can see water doesn't come from the blood into the digestive tract. Everything is showing you the direction that water can move. But water can move from the tissue fluid to the bloodstream and from the bloodstream to the tissue fluid. So you see the arrows telling you that. But what determines whether that water is going to move from the bloodstream to the tissue fluid. Osmolarity. So if blood has a higher osmolarity, are y'all with me? So just think about that. If blood has a higher osmolarity, if there's an increase in blood osmolarity, what do we say that means? There's an increase in solute concentration. So if you increase the solute concentration of water, of blood, what is going to happen to water? Is it going to come into the blood from the tissue, or is it going to leave the blood and go to the tissues? Think about that for a moment. So we have blood osmolarity and tissue osmolarity the same, balanced. Now there's all of a sudden an increase in blood osmolarity. Let's just say you just had some turnip greens and had a bunch of salt on it. So now coming into your bloodstream, you have water, but you also have that salt. So the salt is going to do what to blood osmolarity? Increase blood osmolarity. So by increasing blood osmolarity, you now have a higher concentration of salt in your blood. And that's going to cause fluid to move in which direction, looking at tissue fluid and blood. So remember, wherever there's a higher salt concentration, there's a lower water concentration, right? So by increasing the osmolarity of blood, so basically what you have is this situation we just mentioned. So what we've done is made blood like B. So if you think of A as the tissue and B as the bloodstream, we've increased the osmolarity in the blood. So the concentration, salt concentration, is now higher in the blood than it is in the tissue, which is represented by A. So water is going to leave what? The blood, right? No, I'm sorry. Water is going to leave the tissue and go to the blood. So just remember, wherever salt concentration increases, water is going in that direction. Okay? That may be easier for you all to. Yeah. So whenever you increase salt concentration, water, if you remember, water follows salt. Water is going to move in the direction where there's a higher salt concentration. So by eating all the salt on your greens, you're increasing the osmolarity of your blood. So that's going to attract more what? Water from the tissues. Exactly. So osmolarity is what determines the movement of water by osmosis. Okay? So there, if that was the case, and remember we talked a little bit about this with, why is a person who has hypertension told to reduce their salt intake? Because of this. Right? So if your blood pressure is already high, consuming salt makes your blood osmolarity go up, and that's going to draw more water into your bloodstream, increasing blood volume, which automatically increases what? Blood pressure. Okay? Y'all see that? So I wanted you all to understand osmolarity. Again, osmolarity has to do with the amount of solute dissolved in solution. Okay, so fluid moves between interstitial fluid and the bloodstream. And once interstitial fluid, we get into the tissues, some of that fluid outside of the cell can go into the cell. Okay, so there's that. They're balanced for the most part, but there's some movement of fluid between the outside of the cell and the inside of the cell. Any questions on that? So now I wanted you all to see if you could understand that question. If osmolarity of the tissue fluid rises, think about that. Osmolarity of the tissue fluid. So in the picture, that's the picture in the middle. So you have all those cells, and outside of the cells, it's saying the tissue fluid osmolarity increases. Water is going to move out of the cell. Does that make sense to you? So by increasing the osmolarity of tissue fluid, remember, wherever osmolarity increases, water is coming to that area. Okay? So by the fluid osmolarity increasing, water is going to move from the intracellular space to the extracellular space. That also has to do with tonicity. Remember hypertonic? If you put a cell in a hypertonic environment, fluid will leave the cell. It's all the same. Same thing. Okay? So if tissue fluid osmolarity falls, water will move into the cells. Osmosis from one fluid compartment to another is determined by the relative concentration of solutes in each compartment. So you all remember what solutes are. They're the component dissolved in solvent. You all heard of water intoxication? What is that? So you drink too much water too rapidly, and you can be drunk, or you can die. And I think on the integrity session you may have, I talked about a contest, a radio contest, where I think the person who could drink the most water in the radio studio would win a PlayStation or something. This was back when everybody was rushing to buy PlayStations and they were running out. And a young lady won, but she passed away because she had too much water to drink in a short amount of time. Think about what's going on there. Let's look at those compartments again. And she complained of being dizzy. I guess that's the drunk part. So looking at this, what happens? So she's drinking the water, the picture on the left. All the water goes. Right, so most of the water, not all, some of it continues through. But most of the water is absorbed into the bloodstream. Now where does it go? So now the osmolarity, blood osmolarity is doing what? So if you're bringing in so much water, that's diluting blood, right? So the osmolarity of blood is doing what? Going down. So blood osmolarity goes down. And now where does that fluid go? The water go? To the tissues. And think about tissues that may have a problem with bringing all that water in. That could happen as well. But before that, you end up, think of your brain. So you have too much fluid. Your brain is a tissue, right? So she first complained of a headache, headache, dizziness. So what's happening is all of that water, excess water, is coming into brain tissue. So the brain is doing what? Swelling. Okay? And there's nowhere for the brain to, the skull is in the way, so the brain obviously can't swell like your arm could. Your arm could continue swelling for a longer time than your brain could. So in a short amount of time, that's exactly what happens. Now, usually it's really hard almost to drink too much water. It's probably just drinking a gallon and just non-stop, because our kidneys work pretty fast, right? So usually if you're drinking a lot of water, you're also what? Running to the restroom because your kidneys are getting rid of the excess water. But in that case, she was drinking too much too rapidly and passed away, unfortunately. So that is called water intoxication.